I need to do part B?
So on the finals, it leans towards A or B.
You ready for both? I should. I could have given you a study guide that SEMO gave you. All right. So stripping down part B to the skimpies. What would part B be on its skimpies? .7. Natural log of x. Okay. Now, there's two different things you can do on this. You can still do the xy table. Just keep in mind that your -1, 0, and 1 is going to be on this side. Okay. Now, you could go ahead and write this as an exponential. You could switch this to take this log base e that's down here. It goes over and bumps up the y, and it leaves the x over here. And you can work it just like we did the last problem by plugging in -1, 0, and 1 in for your y. The way that we did it was we said it's always going to go through the point 1, 0. That's what was in the exponent. Now, the way that we did this a month ago was I said it's always going to go through the point 1, 0, and it's always going to go through the point of whatever this base is down here, Brock's 2.7 and 1. And we just use those 2 points. So that's fine. Remember the one like this, they're already going to have it down to the skimpies and a table made for you. So don't fret about this part. All right? That's my hint on this one. I think so. Domain, range, and get the general shape of it. So let's just work it with those 2 points. I really think that's enough. 1, 2.7, 1. I really think that's enough to get us through it. Okay, so the rest of the problem, it says g of x equals -1/2 of the natural, the natural log of x plus 2 minus 4. So which number do you want to work with first? Plus 2, how come? It's inside. So that plus 2 is going to move everything which way? Left 2. So it's going to be at 0.7. Yeah, -1. Yes. On some functions, it does not. On some functions, it does. Remember, I always want to do this. I always want to do the vertical translation last. So, which number are we working with next? The 1/2. Okay. So this is. I know this one's going to be a compression this time. It's going to be a vertical compression. Okay. And then a flip. Good. So it's going to come down to 1/2, and it's going to flip down to here. My pen's a little bit off. That shouldn't be as quite in the middle as it is. So it came down, so it's only half as far from the axis, and it flips down. This x did the same thing. It came down to 1/2. Half of 0 is 0. And if it flips over the x-axis, it's still on the x-axis. So it's still there. And then it's -4 does what? Down 4. 1, 2, 3, 4. Our question is, which way is this thing supposed to be going now? Up, down? Where's the asymptote? -4? Remember, everything switches between everything switches between exponentials and logarithms. Last time my isotope was running horizontal. So this time my isotope has to be running which way? Vertical. So it was on the y-axis, so now it's going to be where? It moved as far as everything did left or right. Everything moved to the left too. So my isotope is going to be over here. That makes it a little bit easier to draw. I have to approach this. And that's what it would look like. It will. It will say write the if this is on there, it will say write the equation of the isotope, and there will be a blank for that. It'll say write the domain. There will be a blank. I would do the inside first every time. All right. What's the domain? Range? Good. You be able to do that tomorrow? All right, ball's in your court. You have plenty of homework problems you should have, and you have these two problems you can rework. Which one do you say? 3B. 3B. All right, 3B is asking for a difference quotient. And then it will give you the difference quotient. And so the very first part of this, what it's going to want you to do, let me color coordinate a little bit. It's going to want you to do is f of x plus h. So it's wanting you to rewrite this f of x instead of using x though. It wants you to plug in x plus h in for both of those x's. So what that's going to look like is this. Okay, step 2. Step 2, it wants me to subtract off the f of x function that they gave me to start with. They purposely messed up. What's wrong with that? Okay, so I do need that. I want to subtract off the whole f of x function. Okay, so let's use parentheses on there. Step 3 is my favorite. It's the easiest. I'm just going to divide everything by h. Now from here, it's just I just have to get rid of all my parentheses. Okay, and then there'll be a check step in here for me. So I get -3. Let's see, that's going to be x squared minus 6xh minus 3h squared. If you need to write this out twice and FOIL it, go for it. That's what it would give me if I FOIL that and distribute a -3. Plus 4x plus 4h plus 7. Distributing through the negative, plus 3x squared minus 4x minus 7. It's still all over h. Now here's my check step. Everything that does not have an h on top should cancel if I've done all of this algebra work correctly on top. So that's gone. That's gone. Hopefully this -4x cancels. It does. So everything that's left on top has an h. which is good because it will always cancel. That will make it so it cancels with the h on bottom. So if I just divide each term in this numerator by h, I get negative 6x minus 3h plus 4. Here's my final answer. Like if I was to FOIL this, I would get x squared plus xh plus xh plus h squared. So I get 2xh times a negative 3 is negative 6xh. 7. A and B. Yeah. Well, it's going to be easier to get the domain and range from the graph either way. 7A. It'll be closer to B. Just do B. 7B. Remember all those little pesky parent functions? It's okay, I still recorded all my lessons. There wasn't one at all until I got the second draft. Do what? I did? I don't remember. I don't remember what I said on Thursday. Might be. I said there are some on the study guide that are. All right, so x cubed minus 2. What's the parent function there? Snake on a plane, right? Snake on a plane moved which way? Down 2. You might. Okay, but I don't want to cross the 1. I just want to draw this snake on a plane where x is less than 1. So let's find 1 right there. How am I going to show that it's strictly less than 1? All right, awesome. Absolute value. What does absolute value look like? A v, right? A v. So I'm going to come over 1, 2, 3, 4, 5. I'm going to draw a v. I remember working this. I don't know when it was, but someone asked me what kind of v. It's supposed to be just a perfect v. But I only want this perfect v between 1 and 6. Remember, these are going to pass the vertical line test. So just between 1 and 2, 3, 4, 5, 6. Ooh, shrink this thing all the way down to here. Now, once it can be greater than or equal to 1. So how do I denote that? Close that. And then strictly less than 6. So back to an open. All right, 4. Ideally, it's going up a perfect diagonal from here. So yes. 4. What does 4 look like? Constant. It's just a constant at 4. And it just wants it so it's at 6 or bigger. So 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4. It's just horizontal line. Oh, well, you guys already know how to domain and range it. Range is tricky. Now look, let me talk about the domain. Excuse me. All right, let's talk about the domain first. This thing's touching everything to the left. It goes to 1, it jumps up, it's still touching every value. Even on those jumps, every x value between negative infinity and infinity is accounted for. So we're good there. Okay, the range. Well, it starts at negative infinity, correct? Okay, it comes all the way up to what value? Notice I'm starting at the bottom. Negative infinity all the way up to negative 1. Does it touch negative 1? It doesn't. It's a parenthesis. Okay. And that it skips all the values from what? Negative 1 to 0. But does it touch 0? To touch 0? That's supposed to come down and touch 0. It's absolutely right. So it does touch 0, and it touches every value going up until 4. Does it touch 4? Yeah, it's touching 4. So that would be the range. Start at the bottom and just look at all the y values and see what's being touched. There's more pre-cal students here than not here. That's impressive. The rest might have the flu from me. I don't know. Is he? That's sad. Maybe college will be easier than this. Yeah. All right. Negative 1. It didn't actually ever touch negative 1. It got really close to negative 1, and then it stopped. Huh? What's that open circle mean? Look where the yeah. It did touch it. It's just my because it's sitting on it. It's touching it. There's a problem like all of them. 9B. This is what you guys just did awesome on, so not too worried about this one. Where's some shading issues? That's gross. I don't want to do that. Did you multiply by 15? I can. They want to multiply the top one by 15. All right.
See, I switched. I multiply by itself.
Is that 6y? I guess. There's no fractions now. That is kind of nice. All right, I'm going to make a mistake. You guys got to find it. Too many smart people in here. So that? Is that right? I didn't work it this way. I'm just trying to get in y equals mx plus b form.
I got 5 and 2.
5 over 2? Good.
Well, 15 divided by
But you went ahead and subtracted this first though, and then did that. It'll get you the same thing. That's the way I worked it. All right, -5 halves. That is right about there. And I'm going to rise 5. 1, 2, 3, 4, 5. Run 6. Am I doing a solid or a dotted line? I have a line tool up here. Nice solid line there. And I'm shading which side of it? Oh, great. All right, I'm going to erase my workspace here. This next one will be a little bit easier to get into y equals mx plus b form because I just need to add x over 6 over to both sides. Now, that's the same as 1/6 x. Dividing something by 6 is the same as multiplying it by 1/6. Some of you, that's all you're going to take away from tonight. All right, so I'm going to rise 1, run 6. Am I doing dotted or solid? Man, it's boring. Above or below? Sorry, the live wasn't working. It would go and it looked really cool, then it just stopped. So where am I shading? What's the domain and range? I'm just kidding. You can't do domain. You can, but we're not going to.
So after you minus the x over 3,
you multiply by the reciprocal. That's what I was gonna do, and people said they want to multiply by 15. It still got us in the same spots, whichever way looks best for you. So I should have asked you to bring me a cabrito special. Yeah. I would get bonus for a cabrito special.
So, CA, if it's like that on the final, but I mean, apparently I heard that you told him.
Don't worry about it.
You should do 10A.
You said it's not.
I shouldn't.
But you should do 10B then.
I will. Jumping ahead to Tuesday already, man. I heard 10. I'll come back and do it though. Oh no. That line didn't erase. Question is 5A. I'm sorry, 10. What was it? 10B. 10B. I choose B. B. All right, what are we doing first? Make that a Y? I like that. That'd be a little bit easier to work with than an f of x through the whole thing. Multiply by 7 minus 4x. So I'm going to distribute this y through. So I get 7 minus 4xy equals negative 3x. Add the 4xy. How come? I agree, but okay. My goal is to solve this for x. I'm going to go back to my algebra roots. What other variable I'm solving for? I want to get them all on one side. So, problem is I have two x's in here. I want to narrow this thing all the way down to a single x. So the whole idea of getting every x on one side was that I could factor it out. Now here's the thing. I want your answer as a function of x. Remember, we use this inverse notation on it. And so I haven't. The whole idea of these 2 days in class was that we switched all of our x's and y's. So I'm just going to make those y's x's. That's all I did. Oh. Yeah. What's the domain down here? What can x not be? You guys might be saying it. 3/4. X can't be 3/4, right? If I do 4x minus 3 cannot equal 0. So add 3 divided by 4, x cannot be 3/4. Right? That would give me divide by 0 error, make my calculator say error because I'm dividing by 0, and it'd say domain error, correct? So domain on this can be anything from negative infinity to 3/4, and then from 3/4 to infinity. Now I'm going to jump around a little bit here. So you guys work it out, and you find me the domain up here on my original function using that same idea. Check with your pod or your shelf. Not equal to 0. Not equal to 0, because it would give me a divide by 0 error. It's okay if it's positive, it's okay if it's negative. It just cannot be 0. Yeah. Because I can do 0 divided by something. I can. Hey, this is not a new concept. If I pick up Emily's calculator right here and I hit 9 divided by 0, it tells me error. You guys have known that. I am saying right here that if I put in a number and divide by 0, it will say divide by 0 error in my calculator. Okay. So what's the domain of the original function? 7/4? Yeah. Using what you know, this is a rational function, so there's actually going to be a vertical isotope there. So it won't ever touch the vertical isotope. Now, you might be thinking, oh man, we're only halfway through, but remember, we switched all of our x's and y's, right? What was my x's just come down here and become my y's. Okay, what was my x's at the end was originally my y's. I just switched my x's and y's.
Yes, you can.
You can have out your in behavior one. What was it? 5? 5A. Hey, that's a good one. That's a good one. That's why I put it on there. It was something I did skip. It's one of those things, if I skipped it, then they were going to put it on there like they did. And if I would have went over it, the headache of it that day, then they would have left it off. So. Yeah, but then whenever I get canned, and then it doesn't cover like the rest of my life. Yeah. Yeah. The what? That's how much I curve every test. Up to 10%. Yeah, so by the third highest grade. Now I understand this problem looking daunting because we only worked with linear ones because that's all that the syllabus said to cover. It said just cover linear system of equations, and they said here, take this one that's not linear. But I assure you, the way that we learn to do linear equations will work with this as well. All right, just be prepared to have more than one answer. So, what are you thinking? Elimination or substitution? It's going to be really easy to get x or y by itself, isn't it? Which one do you want to get by itself? It doesn't matter. Yeah, it's going to be. I heard get the x by itself first, so let's divide both sides by y. So that's going to make this x up here go to 3 over y squared plus y squared. Understand, I just did a substitution there. No, that doesn't work. Now, it'd be really nice not to have any fractions, right? Multiplied everything by y squared. Well, unfortunately, it gives me y to the 4th. But it's okay. It'll buff. I'll multiply this by y squared if it cancels from y to the 4th. It went to the 3 and the y. That's a 9. Now it's not quadratic, but it factors like a quadratic. Let's split apart these y's evenly. Man, that's looking rough. 2 factors of 9 that add up to give me negative 10. Disagree. Negative 9 and negative 1. So that gives me y squared equals 9. Y would equal, careful, plus or minus 3. Y squared equals 1. Y is going to equal plus or minus 1. We're going to have 4 inches on this. These 2 lines, what are they? That is a maybe a hyperbola and a circle. They're going to intersect 4 times. All right. I know all the y values where they intersect. 3, negative 3, 1, negative 1. Just got to find the x values. Let's plug them in right here. What's 3 divided by 3? 1. What's 3 divided by negative 3? It's 3 divided by 1. It's 3 divided by negative 1. No. No. Yes. So. Everything's worth different points. They've assigned points to everything based on difficulty. Does it not work?
like if you had plus or minus 1 and plus or minus 3,
Yes.
and you plugged it into like 3 over 1 equals negative 3, that would work, right?
Yeah, you can't mix up the positives and negatives. I would like to see all 4 of them written down. It's no longer than that page. 11 and 12. I'd like to remind you that this is going to be you guys working this tomorrow and not me. It's going to be on how well you guys can work it, not watching me work it. You guys definitely need to practice. So just want to put that out there. The question was number 11. I am not drawing that, so you will have to help me. I will halfway draw it. Tell you what. Increasing, decreasing, constant. Okay. Imagine Mario running on this. Won't do that. I'll bust you tomorrow. Until the last bus comes. All right, increasing. I just want to know, where is Mario running uphill? Where's he increasing? Just give me X values on this. It's going to say it wants interval notation on this. Remember, all of my interval notation has focused around the X values except for domain. That's the only thing I've done Y's on. So, where does he start increasing at? -6 to 2. All right, and then he's going to increase again right here. Eight till what? All right, it looks like he's only decreasing one time. He's only going downhill once. What are those X values where he's going downhill? 2 to 8. I guess I could have got that. Well, so he's not constant anywhere. If he was constant, it would be like on that constant that I drew earlier, the 4, where he's running straight across, horizontal. Okay. Yeah. Oh, domain, we got this. Domain, smallest X value. Does it touch -6? How do I show that? And does it touch every X value until what? 11. Does it touch 11? That was domain. Range. All right. You can turn your paper 90 degrees and do the exact same thing again, or you can just think about it in terms of Y. So, don't turn your paper the wrong way, though. So turn it so the bottom's to the left. You can just do it again. No, the other left. Okay. So you can just do domain again. So I leave my paper upright because I'm always afraid I'm going to turn it the wrong way. So bottoms out. What is the lowest point that it touches or almost touches at the very bottom? -3. Does it touch -3? Okay, it goes all the way to what? Awesome. That graph is right out of the old college algebra book. All right, C, D, F of F. Is it okay if I write like this? Now remember, on these, I want to start on the inside. Now this is a very easy composition with a graph. If they were to give me 2 functions like they normally do on the final, this would have been a lot harder. So I just want to find F of -3. I want to find the function value when the excuse me, when the inside, the X value is -3. So let's go on the, let's follow this x value, go on the x-axis over to -3. What's the y value there? It's 0. So I'm going to replace that f of -3 on the inside with a 0. So now I'm just going to do the same thing. I want f of 0 though. Go back to 3. And that would be my answer. Some of this kind of jogging your memory, ringing a bell. It's f of x. It's x. The function value, the f's, are your y values. It's asking for your algebra is going to be more interested in the y values. No. That would be f times. That would be f. That's how it would have to be written. This is a composition of functions. So next year in calculus, we're going to be doing differentiate. This is going to have a totally different differentiation rule than a multiplication like you did. Find the values of x such that is that part E? Yeah. All right, so on E, it says find the values of x such that f of x equals 3. Remember, f of x is just the function value of x, which is a fancy way of saying y. So you can change the f of x to a y. It's just saying when y is equal to 3, what x values are we talking about? So I'm just going to find 3, and I'm just going to trace it across and look at what two x values they're talking about right there. What are the two x values? If I even came close. 0 and 4. And then part F, I just asked the reverse of that. I want you to find the y value when x is -3. We already did that, didn't we? Which one? 14. How do I get rid of these? Like a back button?
Is there like an eraser?
A back button would be good. Oh, geez, that's good. There we go. Whoa, redo. What'd you do? Oh, I thought you did something. Hold on. We just activated something. Don't clone it. There we go. He activated the mouse.
So I have a question.
Yep.
So like 12A is fine. So the question to find negative over today.
And that will be given to you on the test. I just saw that. No, it says this is a useful equation. No, it just says it at the top. It just says it at the top. It gives you a couple of equations that'd be useful. All right, part A wants me to find the Haas and Vaz. Haas and Vaz. My daughter has a friend in 2nd grade. Her last name is Haas. And so every time she talks about her friend. This is number 14. Haas. How do I find Haas? 2? Top or bottom? That's a good question. Remember, the Haas is a competition between the top and the bottom as to who has the higher degree. And if the bottom wins, there's not one. At the top, I'm sorry, at the bottom wins, it's at 0. It's the x-axis. If the top wins, there's not one, right? And if they're equal, it's a ratio of leading coefficients. What is 1 divided by 1? Y equals 0. Oh. So I'm going to have an imaginary line going through here that is going to model the behavior of my graph as I exit the sides of my function. Now, do you want to work this safety Steve or dangerous Dan? So we did dangerous Dan. Now you guys don't have any idea how to do this. Safety Steve will maybe. I know, because we did dangerous Dan. Verticals. Where do I find my verticals? The bottoms, right? Because that's where I'm going to have the domain error. Okay, that's where I'm going to have these vertical lines that I am not allowed to cross by any means. So I can factor this out, yeah. And so I get x equals 0, x equals 4. So that means I'm going to have one right here on top. 1, 2, 3, 4. So we had several that look like this. And I promise you tomorrow you will not have, this is Tuesday, you will not have more than 2 vertical isotopes. I'm pretty sure. Now this test does do a good job of kind of stepping you through the problem. It's going to now ask you for any isotopes. Intercepts. My medicine's starting to wear off. I can feel some chills coming. X-intercepts is the zeros that come from top. We sometimes we call them the isotopes from the top, right? So the x squared minus 4 equals 0. You can factor that. I'm old school. I just add 4 to both sides and remember my plus or minus. So I'm going to have them at 2, 0, and negative 2, 0. Here and here. That's the only place this graph is going to touch the x-axis. That's going to be helpful in a minute, all you dangerous Dans out there. Okay. Now, how do I find my y-intercept? All right, plug in 0 in for x. Go ahead and plug in 0 in for x up here in the original. Tell me what you get. Negative 4 over 0, right? Thank goodness, because I put a vertical isotope here, and I just said I am not allowed to touch this vertical isotope, which is at 0. So I'm not allowed to have a point on there, okay? That might not be like that on Tuesday. Heads up, just so you know. Haven't worked it yet, but we'll see. Now, I plugged in 0 in for x, and they told me, gave me something undefined. Because I was looking to see where the y-intercepts are going to be. For finding y-intercepts. That's an algebra 1 trick. Now, here's where Safety Steve and Dangerous Dan differ. Now, Dangerous Dan, remember, did all of his homework, did really good on the quizzes, and understood the homework. So Parker cannot be a dangerous Dan. All right. He's going to need to go safety Steve. And so what Parker's going to do, he's going to say, well, I need to plug in some values over here. I'm going to plug in 1 and 3 and 1, 2, 3, 4. I'm not going to plug in anything on there, but safety Steve is going to go ahead and plug in these 4 values in for these x's up here. I chose stuff that I haven't already plotted. I know I'm going through this point and this point, and so I just chose points that were around them. On either side of every isotope was our rule. That's fine. So you can check that to make this problem get over with. Dangerous Dan says, hey, I remember Mr. Lovelace saying that I'm not allowed to touch the x-axis except for these 2 places. And I'm supposed to approach the isotope. So this has to be here. Because I'm not allowed to touch the x-axis unless it's here or here. I'm only allowed to touch it right here. So the question is, oh, save that, just a minute. Question is, in the middle, is it going to U or is it going to snake, in which way? Okay, Mason graphed it to see that it is going to snake. Okay, Brees just said what? He's if the power is odd, where is it at? Where's my 2? If the multiplicity is odd, it goes through, and it does. Now, safety Steve, he plugged in 1 and got 1 squared minus 4 is negative 3. And then 1 squared minus 4 is negative 3. He got that it's going to go through the point 1, 1 right here. And then he plugged in 3, and he got 9 minus 4 is 5. He plugged in 3, and he got 9 minus 12 is negative 3. Negative 5/3 is like right here. So safety Steve feels very confident in his answer that it does snake. It's just what power it's being raised to. So like all of these are multiplicity 1. If I was to factor this, they were multiplicity 1, so everything crosses. It also works for the isotopes though, because I actually crossed it and came back up here. If it bounced, it would stay on the same side. I honestly would go safety Steve with this. You're going to have time to plug in 2 points. Yeah. Or you can plug it into a factored one if you have a factored one. Do what? $15? 15, they were nice on 15, I thought. Why don't you choose one on 15? Because they're both so similar. B? Okay. B. Now look at the last part of it. You can leave your answer in factored form. That's means it's probably not worth that much. Means you don't have to, oh no. All right, we're doing 15B. So P's and Q's. Remember P's and Q's? We had to check our P's and Q's, which one worked. If you've done 16, 17, nope, 16, 16. If you've done 16, that's where that fun comes in. We're actually working the opposite. They're telling me which of the P's and Q's work, what your final answer is. What is the original equation you're starting with? Okay. So, do I need to reteach this or just jog your memory? Okay, let's reteach it. So what I'm saying on 15, if I'm working this in reverse, I'm saying that the answers at the bottom were x equals 0, x equals 3, negative 3, right? And x equals negative I. Oh, good catch. Well, I didn't put that one on there though, Madeline. Madeline says if negative I has to be a 0, then positive I has to be a 0. Complex conjugate theorem, okay? They come in pairs because if I'm taking the square root of something, it's going to be plus and minus on the other side. Good. So let's think about what was the step right before this, right? Everything was in that factored, or everything, this probably looked the same. This, let's see, 3 got subtracted off both sides, so I had an x plus 3 over here equals 0. Over here, let's see, I subtracted I from both sides, so remember I'm reteaching this, so I'm not jogging your memory here. I have this equals 0, and here I probably added I to both sides, so I probably had an x minus I. Again, I'm working in reverse. Imagine if I was to add I to both sides, I get this, right? Imagine if I was to subtract I from both sides, I get this. So let's think about what I had before this. I had everything in a factored form where everything was equal to 0. So that meant that I had x plus 3, I had x plus I, and I had x minus I. Right? So that meant that either x equals 0. The only way to get 0 is whenever you're multiplying stuff together is that one of the factors has to be 0. If I have a times b times c times 0, what does that equal? 0, because you at least have 1 0 in there. Doesn't matter what a, b, and c are, unless it's infinity. Then you get into some kind of weird indeterminate rules, but you can worry about that in calculus theory. And so this is factored form. Remember what that mean bald guy made you do a couple months ago? He made you multiply all this out and then get it all looking good. This is factored form. Oh, wait, we're not done. We're not done. Okay, first of all, it says degree 4. Fundamental theorem of calculus said that the number of zeros must match the degree. So I have 1, 2, 3, 4. Okay, so we're good there. It says leading coefficient is what? All right, phew, all right. That's all I did. $16 just the opposite. They're going to have it multiplied out, P's and Q's, factor it, synthetic division. 1, 2, 3, 4. Yeah, make sure that it's gonna work as a check for yourself to make sure you get all the complex conjugates in. Having a coefficient in front isn't what makes it 1. The fact that x could equal 0 could make it so that it makes it so that it is a 0. Yes. All right. $17. I can, or you guys could. Right.
16A.
One's the leading coefficient. So it looks like it's a 0 floating in there, but just make sure you read the question. So. Do you have any anticipation of working any of these later? Yeah. All I'm saying is if you go back and look at your notes of some of these, I tell you exactly where each one is. It's going to click better. I know going over this is fun and everything, but if you don't look at it and remember some stuff on your own, it gets harder to remember. I'll come back to 16 if I need to. I think that's the way I taught it. I honestly don't remember, and everything I remember is coming from the first test because I just printed off the second. Because remember they switched tests, and I was worried about getting this in your hands while I was still alive. I would work. They're both or equal to. I would work 17A. It's a little bit harder. Do I now? I've worked this one. It's like that one. Everything I've said for sure tonight, I'm just not sure on this one. All right, I would highly suggest 17A just because it's a little harder than 17B. If I was to work 17B, what are my zeros? Go. What's the first one? 3, -1, and 0. Do you guys see where the 0 is? All right, it's the same one as this one. So watch what I do with the zeros here in just a minute, and you guys can apply it to 17B on your own. All right. If you have questions on that, you come see me at bus duty and hang out with me and all the cool kids. Whoa, to the 4th? You know what? Someone over here is one that worked though. Okay, so this is mega number line problem. What are my zeros? -2 and 7, that's it. I do. Well, intercepts. By the time we were doing rational functions, I switched the name of this to critical numbers. Critical numbers. So the critical numbers of this are here. And then we just simply plug in something from each interval and see if it works. Plug it into the whole thing. I'm looking for stuff that is greater than 0, greater than or equal to. We'll talk about that with our answers in just a minute. So I'm going to divvy this up because to that 4th power and to the 3rd power, I'm not going to be able to do this. So so these two tables, you guys plug in something between -infinity and -4. -2 to 7 is a really nice number. These middle tables right here, -2 to 7. All right, everybody over here, 7 to infinity. So it's gonna be nasty, but look, I'm just really interested in if it's positive or negative. Keep those positives and negatives straight. I'll show you a shortcut of what I do once you guys get your numbers. You have 7 to infinity. See if it's positive. Let's see if it's positive or negative. I'm looking for stuff that is greater than 0, so that's a good thing. I'm sorry. I might be wrong. I'll go back and check it in just a minute. All right, sounds like you guys got it. Here's what I do. Here's my shortcut. Are you ready? Remember, I'm just interested if it's positive or negative. I'm going to choose the hardest interval. I think negative infinity, -4. I heard people throwing out a -5. -5 plus 2, that's negative. Anything to the 4th power is positive. And then -5 plus 4 to the 3rd power, that's going to stay negative. A negative times a positive is a negative. Negative divided by negative is a, so it's a yes. I'm wanting stuff greater than 0. It's a happy face. Okay. See how I avoided all the numbers altogether? I didn't have to worry about them. All right. Did you guys get the? Did you guys get 0 to work? They work. Did anybody? Did I skip this one? All right. So here's that trick again. Let's plug in -3. That's going to be a negative. Anything to the 4th power is positive. And then -3, that's going to be positive. So, no, that doesn't work. No. I said a lot of times there will be a pattern on it, but these that have the higher exponents. Did 0 work? It worked. Did 8 work?
Yeah.
Remember your multiplicities? If it's odd, your happy face changes. If your multiplicity is even, it bounces. It stays the same. Remember your multiplicities. If it's odd, like on the -2 and -4, it changes. If it's even, like up here, it bounces. It stays the same. I'm full of surprises. So I need an answer on this.
So you have to do. You not put -2.
Sometimes. -4, parenthesis or bracket.
No, because it equals 0 on the bottom.
Comes from the bottom. It'll give me a divide by 0 error. All right, everything else comes from the top. Since you have back-to-back brackets here, you can just say -2 to infinity if you wanted to. Comes from the bottom. If I could touch -4, it means it is equal to -4. It give me a divide by 0 error. Bottom is always parentheses. I have. Feels like my whole last 5 months has just been in repeat. What would be different if this line wasn't down here? It would all be the same? If this was strictly less than, what would be different? There'd be no brackets. Everything would be parentheses, automatic. Okay, good. So the part B is a little bit easier now, right? You know your zeros. Put those down here. Do your test points. Use my shortcut if you want to. Plug in numbers if you want to. You're going to have time for either one. So I would like to use brackets on everything, okay, except for infinities and except for the numbers that come from the bottom, because that'll give me divide by 0 error. So I'm going to go back and put parentheses on those two. Everything else gets a bracket. Okay. You out? Good luck. I'm close to my bedtime too. Yeah. Who's grew? What is wrong with you guys? It's grew. GRU, isn't it? Yeah. So what are you gonna do? Because I know you're not gonna go home and work any of this. If you went home and worked for an hour and a half, for as hard as you have listened, and did half as many problems, would you get anything done? Really? Okay. This we're looking for a population of time t. So this is going to be your initial population. I can't remember what I use in here because I teach this in every class. PERT, yeah. PERT, I'm going to use P naught e to the kt. P naught, remember, is your initial population. K is the growth factor. T is the time. Remember, we spent an extra day on this. Something happened. It is, we're going to consider it continuous growth, this population. Because it's not going to be like all of a sudden at the end of 1 year, they grow. It is PERT. It is PERT. In what? This is a good study guide. All right, GRU starts with 50 minions. It's the P naught. All right. E is Euler's E. Find the rate growth. Oh, I should read the sentence above it. The minions reproduce and triple every 3 days. So where'd I put the 3 at? 10 days. So what? 3, 10, triple what? 10 for T, 2 for T, 10 for T, 3 for 2 for T, what? Someone said it over here. 150, right? If I started with 50 right here, 10 days later, I'm going to have how many? 150. The growth factor, I'm wanting to know what the continuous growth factor is, K. And see, if you look at your notes for 10 seconds, you would have realized that, and you could have saved yourself a trip here. It says 4 decimal places, please. I don't know what it is. I used to be able to do that in my head, then I got the flu. That does sound familiar. I'll go with it. So how many minions will there be after 24 days? So my new equation now is this 50 minions that he started with. Suppose that I do not know the days. I'm just going to leave that as a t. Okay, so after 24 days, where am I plugging the 24 at? Okay, so plug in a 24 right here for this t. And that's going to be a calculator problem. I cannot do that one in my head. So let's go ahead and call it 699 minions. 699 minions running around. going below. Some have one eye, some have two, some have hair, some don't. I would fit in well with them. Huh? So, when will Gru have 123 minions? Well, it'll be before 10 days. Give me 2 decimals. 8.19? Where do I plug in the 123 at? For the population. The population after T days is 123. He started with 50. Its continuous growth rate is 10.99%. I want to know how much time passed to go from 50 to 123. So I can use the same steps I did to find K. I can use it to find T. Okay, I'm not going to come out with a nice natural log of 3 here. It's going to be natural log of 123 over 50, whatever that is. Go ahead and divide that out. Give me 2 decimal places. Should be less than 10, because at 10 days he had 150 minions.
I got 8.2. Yeah, I got
8.19. So divide by 50. And then when I'm going to change it from an exponential to a logarithmic function. So that means it's going to become a natural log. And then whatever that gives you, that nasty number, divide by your 4-digit growth rate. I'll get it for you. Those are very good questions for the next 2 days. Any holes that we had, just come see me tomorrow. I'm just not, before school will be fine. I mean, I'll still answer more if you guys want to. But. Do what? There's a negative b over 2a equation. H equals negative b over 2a. And then you just plug in that number back into the equation. That tells you the k. Which one? You plugged 6 on this one? Yeah. The vertex is 6, negative 25. The vertex is a point.